Good afternoon, everyone. So glad to be here today. As I was introduced, I was a PhD student here. I graduated. I'm a KTH alumni. Graduated 3 years ago, and today I work in the financial industry here in Stockholm. Yeah, my name is Cesar, and today I'm going to talk about the software supply chain of Agentic AI. I'm going to talk from a user perspective. Uh, First of all, quick disclaimer: this talk is not about byte coding or the risk of letting agents to write code for us, or the implications of that. And also, today is the industry is moving quite fast, and we are allowing these agents to import things for us. But I'm not gonna cover that. This talk is more about coding, which today it doesn't matter write the code if it is an agent and human. There are risks anyways, because in the end what we have is code. At the end of the day, this is the result. It doesn't matter if it is written automatically or not, but this code needs to be maintained, and there are many risks, and that's the thing that we are dealing these days. And every time that we have code, we import things, we reuse things. Today we have dependencies. We are used to have runtime ecosystems running our applications. But this new agentic AI layer brings kind of new things to us. It brings persistence layers. It brings model registries. We have multiple models running on cloud, running on premise. The models have, they are called between different services, and they have states. They have to manage storage, different deployment ways. They are integration surfaces. So the layers of dependencies between different software components have just increased like crazy in the last year with the advent of these agentic AI frameworks. But still, the same thing remains. So the application code could be small, whatever. But the trust boundary is enormous. As we know, there are so many layers, and this is just another layer of abstraction that we are putting with all these agentic frameworks. And the thing that matters in the end is accountability. So this is very important, because, as I mentioned again and again and again, in the end there is always a human in the loop. And today, with all this code and all of this complexity, we still have the same principles. Maybe you recognize this. This is from IBM, 1979. It was written that a computer can never be held accountable. Therefore, a computer was never made a management decision. And this is what I see still today. So it holds today in big core, small core. It doesn't matter. In the end, there are decisions taken by humans, at least for now. And I think that will be the case for the time being. And do you know what is this? This is a fork of cloud code that I did on. It was less than 1 month ago. The code of Cloud CLI was leaked, and then it was available for anybody to look at. And then I spent a big chunk of my night looking at the code. It was so exciting to get this, to have a look at this machine, like how it works. And in the end, it was like a bunch of hacks and a lot of TypeScript and context engineering in the end, but quite interesting. And I have my fork there, and this reveals one thing: is that we still commit mistakes when it comes to our deployment practices. So it was a human error in the end, because more automation and more agentic check-ins are needed. So let's talk about the agentic frameworks. An agentic framework is something that goes in between, the model and the rest of the world. So the is code is framework that facilitates the reuse of AI agents in a better way. So they have inputs, they are handle actions, meaning that the agents can use tools, they have states, and of course, they have to be updated with versioning. And I did a search from the literature, and I found that there are these three layers for these agentic frameworks. The first, there are packages and registries. And there is agentic frameworks and runtimes. It's the code that runs. And then there is all around tooling and actions. So for the first one, I found this paper about upstream composition and risk. So it's a lot about hallucination. So it was in the beginning of the literature. It was a lot about models hallucinated new packages and these kind of things. Today, that is a little bit less the case, but still, there is also this other paper which is about prompt injections and attacks. As you know, there are multiple layers of decisions that these agents need to make. And today, it just increases like crazy. And with the state management and so on and so forth, it's actually hard to keep track. They have a limited context window. They need to handle memory and these kind of things. So another more recent paper is about cross-cutting AI for software supply chain analysis across tool memories, the actions, like everything they do, they try to find a more holistic way. And this is a super recent paper from this month in ICEC. It was a taxonomy. It presented a taxonomy about all the different attacks that could compromise an agentic framework in this kind of setup. So with every new agent capability, it creates a new trust edge, and this just increase and increase. We have the packages, the way they load, the way they use entity servers, the way they execute code at runtime, which is kind of crazy. They have access to your environment. If you use cloud code or whatever, you are giving them access to your batch shell, so meaning that they can import things. But besides that, they also have memory. They have access to a database. These frameworks have intermediate databases where they handle context there. All these databases are, of course, prone to SQL injection, you name it. So the blast radius is just bigger and bigger and bigger these days. So you have this open source software risk that we have been looking at for a while, plus all these new agentic properties that just increase the risk area, right? So let's have a look at the LangGraph framework. I just picked one framework in a specific because that is what I use for my projects. It is not, it's not the property of a big company. So it's more or less you can use it and deploy it in any cloud. This is something that I like, and it looks like it is at the forefront of what's going on. So I use LangGraph. It's an orchestrator, so you can use it to do all the agentic magic and deploy your applications. That's what I use. And the LangGraph it sits in between the application layer and the model. So it orchestrate agents. They have deep research capabilities, way to handle the load of having agentic memory in between, and it also helps with the infrastructure as well, because It has a LangSmith, which is a way to put observability on your AI applications, and it's pretty good. So you have memory, persistence, tool calling, deployment, and SDK, all of that. That now just increase the attack surface. So this agentic framework just amplify the risk because, as I mentioned, they can uh, use tools to execute commands. They handle memory. They have connectors, so they connect to other tools via MCP server, via directly through APIs, all of that. And they have kind of autonomy. So today you put them in a loop, and then just send a request to the model, and then they handle the agents, and at the end you get an output. At the end you get what you want, but what happened in between is not that easy. It's not clear to me. I have tried, so I did many projects, and sometimes I'm just fascinated that how complex it is to look at all these JSON files of memory that are on tool calling that they have. So it's really not that simple once you go into that rabbit hole. And of course, LangGraph is not LangGraph, it's LangGraph for OpenAI, for Anthropic, it's LangChain, there is the Python environment, it is for LechainChain, for all the vendors. So it is actually an ecosystem. So this is an ecosystem of more than 700 different Python packages, even though the core library itself has like only 7 core dependencies, but it's really enormous when you take into account the connectors. And there are, of course, been vulnerabilities from SQL injection to serialization issues in LangChain. I mean, nothing wrong with LangChain. Like, this is normal, and it's just examples of some things that have been going on in the ecosystem. Because every time you put some abstraction, then there is chance to get more bugs, and these kind of things just happen. But there is something that we are putting into our existing very complex software applications. So that needs to be taken into account. So I decided to explore one of my projects to see how was it going regarding this. I choose one project. That is not important. It's just the analysis that I did. So I have just one code base. It was a real project. It's running on cloud. It's in production. It's for real. And I just look at the dependencies, the blast radius that I mentioned, and I found that it depends on 35 packages directly. It is a Python project. It uses LangGraph. It has 138 transitive dependencies. And there is not only code that comes from LangChain, LangGraph. So there is a code that is needed to put it in production. There is a Google SDK, codes that handle databases. There is a lot of native code there. The nice thing is that this is a real code base. So it's a real product. And as you can see, it gets quite complex and diverse. And so I look at from only LangGraph. It has 5 imports, and this is the picture of the dependencies. So I got the 87 packages for free after depending on 5, and these are the 5 LangGraph, LangChain. I use Google and Vertex AI and LangSmith. So this gives you an idea that it's kind of a forest, and I'm not taking into account the integrations, just only the things that I put it into my projects after just using LangGraph. But I will be fine. I mean, after all, it will be no problem because I am using a skill that now checks the supply chain integrity for my project. So looks like this is gonna be the the answer. We are going to use agent to check what other agents are doing. And so this is what I'm doing. So to finish, some recommendations. It is important to still keep an inventory of the real graph from the application that you are doing, that you are developing. It is very important to pin and verify your dependencies, at least to have understanding of knowledge of what's going on behind the scenes. It is important to monitor the agent's state. This is very, very. I would say this is the key thing, to try to put as many guardrails as possible on the tools that they can access, and if they are allowed to execute code in certain environments or not. And the way is to isolate them. So if you are deploying on cloud, something like that, you need to still have a dev environment and a acceptance environment and a production environment, and don't let the agents to deploy on production environment. Please, that's very, very important. I have heard very horror stories about it. And it's very important to automate, because as I showed in the beginning, the cloud code leak was apparently lack of automation and lack of human checks and agent checks in the end. So it is very important to automate everything, make sure that you check your dependencies and keep improving. So these are some of the paper. You are academic audience, so you like papers. Hopefully, we will have more research on this direction. Today, there have been a lot of attention on these specific agentic frameworks in the literature, which is quite good, especially this ICC paper published this year. It's the last one in the list. If you want to look at what paper, this is the paper to look at. So check it out. And that's all for my short talk. If you want to connect with me, talk to me, I have a QR code that, of course, is a link to my website that I coded for you. So let's get in touch. And thank you so much for your attention.
We have maybe time for one question.
Yes. So we could go back to the slides to blast failures when you compare your own project and your dependencies and the cognitive dependencies. It was like the blast failures does. So based on this specific slide of the and one more people, just one. Based on this slide, so it basically means I can see there are some projects already here on the internet that actually allows everyone to take one open source dependency and to write it completely using agents. So it takes the requirements, it takes the test cases. It's purely unethical, but you can do it, and then you'll be in your application. Plus radios. That's completely reset, completely good. So is it like kind of the future of doing scraping the test cases and requirements from open source and providing it all those packages within your application to decide?
I'm not sure if that's going to be the future. Maybe it's going to be, but today there are technical reasons for this not happening. And it has to do with the limitations of the agents. So if you pull in a lot of code, then you will have to maintain that code, and maintenance meaning like having the agent know that this code exists. And today, the more content you put in the context window of the agent, it consumes more tokens. It takes a lot of time to reason about your code base. So it's just not economically feasible. And it's still way cheaper, instead of reinventing the wheel, making the code yourself. Is still not a good deal, because you will have to make the agent know that this code exists. It's still way better to rely on dependencies, from my perspective.
How does the agent know that dependency exists?
Well, you said the document. I suggest this becomes a coffee break discussion.
Yes.
Sorry, a bit behind. Okay, thank you very much.